All right, you should now be able to see my screen, hopefully.
Yep, it's looking good.
Perfect. So hello, everyone. Thanks for joining us today. I'm Luca Nicoletti, an Android engineer working at Triller, and today I'll be talking about Jetpack Compose and how we are exploring and implementing this new technology here at Triller. So let's compose our Trill. I'll be talking about what is Jetpack Compose, what's needed to set up your environment to be able to use Jetpack Compose, the target we choose in our app to go with our first attempt at using this new technology, and then I'll show you some code to get a better understanding of how this new library is used. A disclaimer here, there will be quite a lot of code, and you might not understand it at first. I'll try my best to explain what's going on in the code, but feel free to take any note on the slide number you don't completely understand and ask for a question at the end of the session. In the end, I'll draw my conclusion and the ones of my company as well. Let's start with what is Jetpack Compose. Jetpack Compose, it's a modern UI toolkit provided by Google, used in the Android framework. It's entirely based on Kotlin. All the code in the libraries provided is in Kotlin. And this can be checked as they are developing Compose in the open. It's entirely open source. Jetpack Compose requires a paradigm switch to develop with it. It's not like using a new view class in your layouts. The way we define our screen in our apps changes drastically. And last but not least, it's completely decoupled from the operating system, which means that bug fixes and improvement can be rolled out without relying on a system version update. So as said, Jetpack Compose is entirely written in Kotlin. Also, Compose, it's not only a UI toolkit. There are actually two fundamental components in Compose. One is the Compose UI, the collection of all the libraries exposed from Google, which will allow you to define your views and screens. And the other one is the Compose compiler, which is what is hidden behind the scenes and allow us to use Jetpack Compose the way it's supposed to be used, without the necessity of writing too much code for ourselves. The main building block of Jetpack Compose is the Decomposable Annotation, and we'll see later how it's used. And think of this composable annotation as a keyword. It works almost like the suspend keyword in Kotlin. And here is where the Compose compiler comes in place and does its job. Using this annotation, you signal to the compiler that it needs to change the code we wrote. The composable annotation, as the suspend function, changes the signature of the function to which it is applied, changing the parameter list and the return type as well. This allowed the runtime to calculate and know which function of the composable ones needs to be retriggered and when during the app life cycle. This procedure of invoking the function when it's needed, it's called recomposition. So I'll say the main concept of this new library is the composable annotation, which is to be used on function. As we'll see later on, our interview hierarchy will become just for function. And that's because the goal of Compose is to be functional. So pure and without any side effect. But is it like that already? Unfortunately, it's not. Side effects are still happening, even with this function-only approach. But they're working on moving towards a more pure solution. For example, they have already made all the parameters that the compiler is adding to your function read-only. Another key principle for Jetpack Compose are trailing lambdas, which allow specifying the last input parameter of a function in a fancy and eye-catching way, and we'll see later on how it's actually been done. So I told you about a paradigm shift that is required to start developing with Jetpack Compose. Jetpack Compose provides a declarative API. So the shift needed is from the imperative mindset that almost every Android developer has to a declarative one. Usually imperative and declarative are used side by side to give a better understanding of what changes between the two of them. If you think of a simple layout that has, say, a tower of 3 blocks, the imperative way requires you to lay down each block after the other, whereas a declarative way allows us to define a column or a tower with the 3 blocks. And as you can see from the slide as well, it's way leaner and cleaner how you actually define what you're willing to achieve. The imperative solution that we all know and we are using in Android nowadays comes with a tree of widget or views with an internal state. And we are allowed to manipulate this internal state with several functions that the framework provides, as set text, set visibility, add child, remove child, etc. And this can lead to having illegal states. What happens if you update a view with an inconsistent state from, say, 2 different points of your code, maybe 2 different classes as well? Maybe you set a text from a fragment on a view, and then as this fragment is bundled in an activity, from the activity you hide that view. What happens? Spoiler alert, the view is still invisible. So Jetpack Compose and any other declarative framework, such as Flutter, React, React Native, allow us to describe our UI right now, but for every value of now. And our code will be independent of the previous state. As we have a functional approach as well to declaring our views, we will have data going down from parents' view or components to children or to leaves in the tree, and events going up to avoid side effects inside our smaller component of the view hierarchy. So keep in mind that the smallest and leaner the component is, the less likely it will contain and hold a state for itself. A small note worth mentioning is that Jetpack Compose is still in beta. Its first release version is planned for this year, Google I/O, and right now it's quite stable and feature complete, but might contain bugs. This is the Google way to ask us to not ship production applications yet with this tool. So to use Jetpack Compose, the first thing to do is to download the preview release of Android Studio. The stable one does not contain the Compose compiler I told you about earlier, so you won't be able to work with Compose. You could actually use the stable version to write code and also to run your application, but without the compiler that will change the signature of the function, you might have unexpected crashes and behavior at runtime, which you don't want. So what you need to do is also update your build Gradle file, adding the 3 following things. So you need to set compose to true in the build feature. You need to target JVM 8, so Java 8 or Java 8 in the Kotlin option, and set use IR to true. The compose option, compose compiler version, and compose extension version are as such. There is actually already an update, and the compiler extension version has reached 1.0.0 beta 9. I haven't updated the slide, sorry for that. And then, depending on what you're looking for to use, add all or just some of those libraries to your dependencies. For example, if you're not planning to use the integration with RX Java because you're not using it in your project, say you already migrated entirely to coroutines, you can avoid that package. Or you could avoid the material and material icons if your app has a design system that is different from the material one, just to save some space in your bundles or APK if you're still shipping APKs. So now let's talk about our target and our app a bit. This is our age gating screen where we ask the user to provide his date of birth. At first, it seems to be a really simple screen, just a few labels, an input, a link, a button, and the navigation toolbar with a back button to navigate back. What's interesting here is how the edit text changes over time based on the state in which the screen is. So depending on the user input, this edit text changes how it's displayed to the user. I go through the code we had before, trying to migrate to Jetpack Compose first. It should be code that everyone is familiar with. A bunch of Kotlin lines, some checks, if statement, sums, carrying the XML as well. So here is how we start everything. So from the activity on create callback, we're using view bindings. That's why we're setting the root container as a binding.root variable. Super on create actually usually calls the set content view on that root container. We have a base activity class which handles this for us. Then we set up the views. We observe the states and the events that are sent from the view model, and we also initialize the view model. When we observe the state of the view model, we react to the state based on which actual implementation we receive of the state, and we update the view accordingly. For example, here we have three types of state, three type of possible state: a loading, an error, and the user input. So when there is a loading, we just show a progress dialog. When there is an error, we show a message, which is a banner. And then the main thing is when the user is actually interacting with the edit text. So as you can see here, we update, we call our render function on a birth edit text widget, which is a widget we created. And then we providing all the values. So if the text, if it needs to show an error and if the date is valid. And then we enable or disable with alpha the button at the bottom of the screen. And this is the body of the render function for our widget. This is the only function that our widget exposes. So we already copied the idea of rendering the now from Compose for every now. And here we also use view bindings. And as you can see, there is a lot going on. For every single label, we show or hide it depending on the value received for that label. We change the input type of the edit text based on widget containing a password or not. We render an error if the error is not null, and we show and hide icons around based on other conditions, sometimes more than once a time. This is the set text or hide function, just an extension function that checks if the text provided is not null, and if it's not, it's set into the text view and show the text view, otherwise it hides the view. And we also have two layouts, one from the activity, which bundles the navigation toolbar and the edit text widget and the button, and a slightly bigger and more complex one, which defines our edit text widget that comes with the heading, message, notes, error message, icons, and input field. So this is all the code that we have that we had in place, which was not too bad, thanks to our widget system that we're using. We already in the mindset of using a declarative API, as you've seen, thanks to the render function, which is the only one exposed. And here the result done in Compose with just a few hours of work, not much. And it's a little bit different, as you can see. The navigation toolbar has a wrong color. The edit text doesn't display the blue border for the selected status, but that's because it's just a screenshot of the preview of that screen. I didn't say anything about it, but another cool thing about Jetpack Compose is that it allows you to see a preview of what you're building without actually running the app on a device. All you need to do is to annotate the function that you want to preview with the preview annotation. And there are some limitations though. For example, you cannot have the preview annotation on functions that have parameters without a default value. But you can tweak the preview. It's quite powerful right now, and asking for a specific device frame, specific size of the screen, specific DPI, and Android system version as well. So this is the code for the compose. And again, where it all starts, it's inside the onCreate function of the activities. And it's a little bit different, as you can see. And what we're using, it's a composable function. That is a new method, which is the set content, that allow us to provide another composable function inside of it to be rendered on the screen of that activity. So what we're doing here is setting a theme. And as this screen changes how it's displayed, so we basically have a dark and light theme for this screen based on some conditions that are provided through a parameter from the bundle of the activity. We're setting the light or dark theme inside the age gate, inside the Triller theme of Compose as well, just by this check. We then define a surface and set the background color to material theme colors.background, which is a property that is overridden by the Triller temp function and scope we're already in. And last, we call our composable function that defines our screen, age gating screen. And well, after setting the layout, we also initialize the view model. Note that we're not observing any state at this point. So this is the, sorry. This is the entire screen, and it's entirely described by a function now, which accepts a view model instance. And here I actually forced the dark theme just to take the screenshot to add it to the slides. It shouldn't be there. It should just be the column with the back arrow of top bar and the age gating screen body. And as you can see, we provide data from top to bottom. This is the back arrow of top bar, which actually uses the top up bar, which is a function provided by the framework, fixing its height to 64 dp and filling the width of it. And inside of it, again, using the trailing lambda, we just have an image and a resource with this helper function painter resource. We set content description and we tweak it a bit, adding some padding and making it clickable using the provided function from its parent in order to handle the click. The body itself, it's a little bit more complicated, but we'll go through it step by step. We first have this state saved through observer state, which is a helper function they provide that returns a live data wrapper around the state of that screen. And as we can see here, we can access the state value and the text, or for example, if the date is valid later on in the button. And so we have a column which creates some padding and fix the height of the entire screen. And the vertical arrangement of its children are spaced in between. So that's how I achieved to create all the space in between the two components. So the first child is another column that bundles the header, the body, the text field, and an annotated string. And then the second child is the button, which is at the bottom. And we'll go through every single header, body, text field, and other composable function that we define. This is the header. It just uses the text function, which is the equivalent of a text view for the current framework. And what we do here is just setting the font size, family, style, and weight. And we accept a modifier from the outside in order to be able to set padding or margin from the outside. And this inside is the body. It's basically the same thing, but what we do here, it's using a specific color for it, as otherwise every text by default uses the material.colors.on surface or on background, which is white by default and white on our theme as well. This is the text field. which is a little bit bigger, but not too big, to be honest. So what we do here, it's calling the text field, which is a function provided by the framework. We set the value and we provide the callback for the onValue change. We set a placeholder, and then we start tweaking it a bit. We fix its height and we give padding, filling the width. We then set the colors. For example, for the background, we have this gray scale for 100, and then the indicator are transparent, as the text field actually creates a line under the text field as a focus, unfocus, and disable indicator. So we can't rely on that by default. We need to tweak what we do. Then we gave it a shape as a rounded corner shape with a round corner of ADP, easy. And then we set the text style in order to have the same font and style and weight. The annotated privacy, the annotated text is longer, but it's shorter than using span builders are really used to. So what we do here is we gather the toString with another helper function, string resource, the enter one and the one to make clickable. We get the indexes, we add the enter string to the annotated string, and we then add the style in the correct position of the string, adding as well the annotation, which is an URL from start to end index. Well, it's now pointing to GitHub, just didn't want to showcase our link for the privacy policy. And then we call another, after building the annotated string, we call another composable function, which is the clickable annotated text, which it's just a simple wrapper around the clickable text, which comes from the framework. And as you can see, we give some padding, we provide the annotated string, and then we tweak the style. It's worth noting that the style that we define here inside the clickable text won't affect the one defined previously, which is the one that gives the color to the actual annotation of the string. And last component in this screen is the button, which uses the text button from the library again. And we also need to tweak the style, we change the colors. We give some elevation. We give it a shape in order to have the rounded corner. We fix the height and fill the width. And the button, it doesn't contain a text view anymore, as it's used to be in the view system right now, but it accepts whatever you want as the body of the button itself. And here we're just providing a text. And here again, we're just setting the color to white and tweaking the size in order to adhere to our styling. And that was it. That's all the code we had to do for the entire screen. And so in conclusion, is Jetpack Compose worth using yet? What's the speed of development compared to the standard and quote unquote older way? How fast is the learning curve? And what's required to have it approved in a company? Not all the companies allow developers to jump on board with new technology, especially if this technology are still not released in a stable version. And answering the previous question might help you push forward with the adoption of Jetpack Compose in your company. So in my opinion, it's totally worth it for sure. It's a way better developer experience to write code in Kotlin and handle everything from there. All the layouts, views, screen are defined and maintained by function in Kotlin. It's way easier to work like that. And also, again, comes in place the representing the now of the state of the screen. And the speed of development really depends on what you're building. Let me explain. If you use the material design system, a lot of components are ready to use. You just need to call the correct composable function and you're good to go. If instead your design system differs a lot from the material one, you might need to use core components of Jetpack Compose. So for example, you might need to use, as we did, the edit text and not the outlined edit text that the material library provides. And But this problem comes with the current Android UI system as well, right? Yes. So what's the difference? Well, the difference is that Jetpack Compose doesn't have, as yet, a community of developers using it 8 hours a day. So you might find a problem or something blocking you to achieve a given design for the first time around, and you might not find any solution at all on Stack Overflow or elsewhere. And this can slow down a lot the development speed. One thing that can speed up is that once you've built that single component as designed, you will be able to reuse it as much as you want in your entire app. So it's a build one, use everywhere approach that you provide. And the learning curve, it's the same. There is not yet enough material out there to speed your learning process as much as you want. So the learning phase will be more like dig your hands in the code and give it a try. And that was it. Here are some references from where I took the first section of the slide, alongside reusing some old slides of mine from previous talk about Jetpack Compose, and a nice library, GitHub library, that showcase a lot of Jetpack Compose elements and how to use and customize them. And this last one, it's from Airbnb, and it really helped me going through implementing that screen in a faster way. And now I rushed over the time, so I guess we have a lot of time for the questions. Can you confirm if we have any time for the questions?
Yeah, we've got a few minutes. If anybody has any questions, either use the mic or put them in the chat. We've also put your contact details in the chat as well, Luca, so people can reach out if they think of something later. Quick question from me, actually. Do you think you'll kind of capitalize on your Compose knowledge and start thinking about kind of Compose for desktop and things like that at Triller, or is that not something that you guys would look into?
So for now, we're not looking at using Compose in any other way rather than Android. We are not, we don't have a Kotlin multi-platform project, so we won't be able to share Compose on desktop or web as for yet. And I don't think there are plans for the company. I mean, I can't say anything for the company by myself, but we don't have a desktop platform yet, so I don't think that there are any plan in the near future, at least, to do that.